In this video, we're going to look at 5 through 8. All of these have to do with wholes of graphs, as well as the resulting domain due to the wholes. So in this case, we're going to write the equation in factored form. We have a parabola. We know that the original equation of the parabola without the wholes would be roots of 2 and negative 2, so x plus 2, x minus 2. But since there are 3 wholes here, we need to include those additional factors that would create those wholes. So y equals, we have our original parabola equation, x plus 2, x minus 2. We also can see here that there is a hole at 2. So that would mean that we need an additional factor of x minus 2. We also have a hole at 1, so we would need an additional factor of x minus 1. And a hole at negative 1, so a factor of x plus 1. Important features would include the name of the graph, so a parabola, the holes of the graph, so holes at negative 1 and 1 and 2. And we could also include the roots, so we could put roots at 2 and negative 2, or the vertex at 0, negative 4. All right, on number 6, state the domain of a parabola with an a value of negative 1, a vertex at negative 5, 4, and these holes. If we just had the parabola with no holes and you had a vertex at negative 5, positive 4, with an a value of negative 1, it would look something like this. And the domain would be all real numbers. However, since we have holes at these 3 values, the graph is undefined at those 3 values. So we can say x cannot be equal to those values, 1, negative 4, and 2. You could also say all real numbers except 1, negative 4, and 2. All right, number 7, we're going to write the equation of a line with a slope of 4/5 and a y-intercept of negative 1. So disregarding the holes to begin with, we would have an equation of a line mx plus b. Now, if we're trying to write the equation including all of its holes, we would need a factor of x minus 3. I'm going to leave some space here for this. We'll come back to that in a minute. X minus 3, x plus 1, as well as x minus 10. And we normally don't want to have a fraction in factored form. So if we're trying to change this to be in factored form without any fractions, we can move this 5 to the denominator here. And then that would mean we would end up here with a 4x, because 4/5 x. And since we want a minus 1 once it's divided by 5, we could make this a 5. So this portion right here is equivalent to 4/5 x minus 1. All right, and number 8, we have an expression on the left and on the right. We're trying to decide whether this equation is true or not true, and also, if it is true, what values of x would be accepted, or exceptions. So in this case, let's look at the left side first. If we simplify the left side, we'd have an x minus 4, and then an x plus 4, x minus 4 on the bottom. And then on the right side, we'd have an x plus 4. So if we simplify the left side, we get 1 over x plus 4. And then on the right side, we have x plus 4. Now, solving this equation, we can cross multiply. X squared plus 8x plus 16 equals 1. It's a quadratic, so we want to set it equal to 0. So this would become a 15, and then we can factor it. So x equals -5 and -3, which would be option D.